Okay, this section is about resources, which is an important unit, and we're going to talk about global warming to begin with. Now, the idea of all this is to be able to explain that the infrared radiation is absorbed by the C double bond O, the OH bond and the CH bonds in carbon dioxide, water and methane, and how these contribute to the phenomenon known as global warming. And we need to be able to explain also the greenhouse effect of a given gas is dependent on both its atmospheric concentration and its ability to absorb infrared radiation. Let's try and explain what the actual greenhouse effect is. That there is the atmosphere surrounding the Earth, the gases that surround the Earth, and that's the Earth itself, and over here we've got the Sun, and they're the characters that are involved in this little story. So we've got radiation that comes from the Sun, and that's both UV radiation and infrared. Now, some of the infrared is reflected back into space. Some of it is reflected, and the gases in the atmosphere actually absorb the infrared radiation and reflect them back and rewarm the Earth. So to go over that again, that's radiation from the Sun, which is a combination of UV and IR. Now, some of the infrared radiation is reflected by the Earth and goes straight through the atmosphere into space. Some of it, however, and this is where the global warming comes in, some, and the greenhouse effect, some is absorbed by gases in the atmosphere. And this radiation is then reflected in all directions, and some of it comes back to the Earth, and that warms us up. Again, it adds to the warming from the Sun. The important thing to realise with the greenhouse effect is that the greenhouse effect itself isn't a bad thing, and without it our planet would be too cold to support life. So the greenhouse effect itself is good, it warms up our planet. The problem comes if the greenhouse effect becomes too large, and then what can happen is, and what seems to be happening is, our planet is actually getting too hot. Now, the reason is because the concentration of greenhouse gases is increasing through our use of fossil fuels and other activities. So that's causing the greenhouse effect to become greater, which is causing increased warming of our planet at too fast a rate and leading to the problems. So to summarise that, the greenhouse effect itself isn't bad, but too much of it is bad, and we're creating too much greenhouse effect from our use of fossil fuels, which are increasing the concentrations of greenhouse gases in our atmosphere. In terms of a definition for the greenhouse effect, the process in which the absorption and subsequent emission of infrared radiation by atmospheric gases warms the lower atmosphere and the planet's surface. Let's have a look at some examples of greenhouse gases. Now, the first one is water, H2O. The other one is carbon dioxide. And the next one is CH4, methane. These are the main ones. So how do greenhouse gases absorb infrared radiation? Well, if we look at water here, now from our work in infrared spectroscopy, we'll know that certain bonds, OH bonds being one of them, will absorb infrared radiation, and it causes the bonds to either stretch or vibrate. So this is how it happens, and they can vibrate and stretch in different ways. They can both pull together, both the hydrogens can stretch together, or one can stretch and one can relax, so in different ways. Similarly with the carbon dioxide molecule there that's got the C double bond O, we know that that absorbs strongly infrared from our work in infrared spectroscopy, and again it can stretch in different ways. One can relax, one can stretch, one can relax and stretch, or they can both stretch together. And this is how it absorbs the infrared radiation, these molecules. It's because of the bonds. So to summarize then, these molecules absorb infrared radiation by stretching and vibrating. Now this is what is global warming potential, GWP. Well, it's the ability of a trace gas to cause global warming, and is related to the lifetime of a gas in the atmosphere, as well as its ability to absorb infrared radiation. So basically it depends on the concentration of the gas in the atmosphere and how well it absorbs infrared radiation. Those are the two things that determine the global warming potential of a particular gas. The question is, what can we do about it? What can we do to stop the global warming? Well, the first thing really is to stop burning fossil fuels and rely more on renewable resources like wind power or tidal power, have turbines like this under the sea, and use other things like solar power there, and even our old favourite nuclear power is an option that will actually stop producing greenhouse gases, although there are obvious disadvantages with these technologies that I've just mentioned. We could go to biofuels, where we actually grow material like sugar and get our fuels from that. Overall, in theory, carbon neutral, because the plants themselves that grow will take in the carbon dioxide that's produced when you actually burn them. However, there are environmental implications with using biofuels. You have to use pesticides, which isn't good for the environment, and also there's a lot of energy put into actually getting the fuels out in the first place, so not completely the solution, I don't think. Anyway, all these technologies, it will take time before we use these and can get them up and running for everyday use. So what can we do now? What can we do at this moment in time? Well, one of the technologies that's been put forward as a way of reducing CO2 emissions is something called carbon capture and storage, and it's abbreviated to CCS. Now, this is a proven technology. It does work. If we take North Sea oil and North Sea gas production as an example of CCS, now this natural gas, CH4, the methane, comes out of the well in the sea. It can then go through into something called a reforming and carbon capture process. Now what happens with this is it's a chemical reaction to remove the carbon. So the CH4, the methane gas, is reacted with water gas. And the products are hydrogen and the CO2. So there we have CO2 and hydrogen. Now the hydrogen can be burnt as a fuel. The advantage with that is it doesn't produce CO2 when it's burnt. It'll only produce water, which won't affect global warming. So let's have a look. The hydrogen here is taken away and burnt in a power station to provide electricity. Now the CO2 that's produced, now this is the stuff we've got to get rid of, and this is what carbon capture is all about. It can take the CO2 gas, compress it, and pipe it back into a North Sea oil well. So if you follow the path down, it goes to a North Sea oil well here, and that's been pumped back into the ground where they take oil out. That has the advantage in that it can help take out the oil. So although it costs money to set all this up, you will actually recoup that money, because the CO2 being pumped underground, under the sea, will actually help take the oil out. Now you might say, well, what happens to the CO2 when it's under there? Well, it will stay there quite happily, and it won't come out. Now the question is, how much CO2 can you actually put under the ground like that? How much can the Earth store of CO2? And the answer is an awful lot. In actual fact, if you think of all the fossil fuels that's burnt, or it's possible to burn, then it should in theory be possible to store all the CO2 away so that it doesn't come out into the atmosphere.